This earthquake loss were calculated using equivalent static analysis, equivalent earthquake static analysis in Turkish eşdeğer deprem yükü yöntemi. Okay. These horizontal loss, and today we will see how we are going to assign these horizontal loads to each story level, and we are going to design beams, we are going to model beams, columns, and we are going to construct rigid diaphragms. We will apply dead loads, live loads to the slabs, okay, to the slabs in the building, and we will make some load combinations also. Some load combinations. This is actually, there are more than 17, because in this case we have only 1G plus 1Q plus E. Additionally, we need to consider 0.9G plus 1E, okay? But it is not given here. I'm going to explain this later. Okay? Now let's first solve these quiz questions. Now, for the frame shown in the figure, draw frame local axis on the figure, okay? And this frame is on XY plane, as you can see, okay? XY plane. And Z is upward direction. What was the rule? The rule is, if we have for vertical numbers, two axis is always parallel to X, two axis, for vertical numbers. For horizontal numbers, okay, let's wait some more. Some people are still coming. Okay. Now for horizontal numbers, what was the rule? Two axis is in which direction? Two axis is parallel to in Z direction. Parallel to Z direction. Two axis. What about one axis? One axis is always the longitudinal axis. It lies along the axis, longitudinal axis of each member. One axis. It starts from start end and it goes to end, finish. Okay. For example, for member one, this is member one. Start joint is 1 and joint is 2. Therefore, one axis for this member one, one axis is this. This is 1. Okay. What about 2, 3? This is frame 2, frame member. Start joint is 2 and joint is 3. Therefore, one axis is in this direction. Okay. What about 3? Member 3. Start joint is 3 and joint is 4. Okay, this is different than this one. Because start joint is 3. This is downward. I did this on purpose to see how many of you can notice this. Some students did this correctly, okay, but most of you, for example, some of you showed me the joint local axis. I didn't want that joint local axis. I want you frame local axis. Okay, these are 1. This is 1. This is 1. And this is 1 axis. What about 2 axis? Axis 2. For vertical numbers, axis 2 is parallel to x. Parallel to x. Okay? Therefore, this is parallel to x. This is parallel to x, and this is parallel to x. Okay. 2. What about this one? For horizontal numbers, it is parallel to z. Okay, z parallel to z. Therefore, this is 2. What about third axis? Third axis, we are going to use right hand rule. Okay, right hand rule. 1 to when my forefingers goes from 1 to 2, my thumb will give you the direction of third axis. Therefore, for this case, third axis will be in this direction. And for this case, 1 to, it will be towards the front. Okay, this is 3 axis. And for this case, 1 to 2, this will be again outward. Okay, these are outward. These are outward. Okay, this is the why this is important. Why determining the local axis, directions of local axis is so important. Because you are going to use this, the orientation of columns or beams. Okay. For defining frame section, the orientations is important. Additionally, which moment components you are going to see, okay, you are going to look, is also defined using these local axes. Okay. For example, are you going to look moment 3, or moment 2, 2? What is the direction of moment 3, and 2, 2? Okay. These will be important for 3-dimensional structures. For 2-dimensional, there is no problem. For 2-dimensional structures, as you see, 3 is always perpendicular to the xy plane, xz plane, xz plane. Therefore, for 3-dimensional structures, you are going to look always moment 3, 3. Moment 2, 2 will be always 0 for 3-dimensional structures. Sorry, for 2-dimensional x structures lying on xz plane, moment 3, 3 will be important. Moment 2, 2 will be 0. Why? You see, moment 3, 3 is the moment always perpendicular to the xz plane. Şimdi arkadaşlar, xz düzlemindeki şeyler için moment 2 hep 0. Moment 3 bakın 3 hep bu düzleme dik. Dolayısıyla hep bu yönde momentler. Değil mi? Düzlemsel bir problem için momentler her zaman bu yönde. Yani şu yönde bir moment olabilir mi bu problemde? Can you see a moment in this trade unless you have a force which is perpendicular to the plane? Okay, these are important. Therefore, I asked this, and in the final exam, I'm going to ask these again. Maybe on another plane. For example, this is on xz plane. For example, I'm going to give you another frame on yz plane or on xy plane. Okay, therefore study these carefully. What about joint coordinates? Joint local axis. Unless you change them, they are always parallel to x global plane, so global axis, x, y, z axis. Okay. They are always, joint local axes are always parallel to x, y, z. 1 is x, 2 is y, and 3 is in z direction. For joints, okay, joints. These are for frames. All right, any question on this? Okay, we have a non-prismatic section here. I and 2i are previously defined, having the names I and 2i, all right. And now, we have three, you see, we have three regions here. In the first region, we have a variation in depth of the beam. Okay? In the second region, we don't have variation, it is constant. But in the third region, again, we have a variation in depth, okay, not width. What was the moment of inertia? I 1/12 dh cubed. Okay. Now, what is h? H is this. Therefore, what is the variation here? Variation cubic. Here variation is cubic. Here variation is linear. And here variation is again cubic.
Ya kübik ya da lineer mi oluyor hocam sadece?
Ha?
Sadece lineer mi? Hani bir de prizmatizm var.
Actually, here we don't have variation. Therefore, it is whether linear or cubic. It is not important for this case because I, it starts with I and ends with I. Therefore, where this variation, what variation you choose here, it is not important for this region because there is no variation. It starts with I and with I, no variation. Therefore, it is not important whether you wrote here linear or cubic. Variation occurs, actually let me remove them. Linear variation occurs if width is changing. If width of the beam is changing, it is linear variation. If